The graph of square root of x looks like this. Okay, and if you're ever unsure what a graph would look like, if you're not sure what the rules are, you can figure it out by making an x and y table and getting some data points. So make a quick x and y table, plug in 0 for x, you get out 0 for y. Plug in 1 in for x, you get negative 1 for y. I don't want to plug in 2 because square root of 2 is yucky, so let's plug in 4 in for x, I get negative 2 for y. So my translation is going to have 0, 0, 1, negative 1, and then 4, negative 2. So there's a graph of that transformed graph. Okay, so the rule here is that if you multiply everything in the function by negative 1, so if you change all the signs, then you've reflected it about the x-axis. It's like it's a mirror image on the x-axis down here. That's our new graph. Okay. But now, if you do something to the inside, if you just multiply the domain variable x by a negative sign, then that reflects it about the y-axis. Okay, so let me rearrange this just a little bit. This is the same thing as y equals the square root of negative x plus 3, right? So we can factor it a little bit more. This is negative x minus 3. You don't necessarily have to do this step either, but look, the starting point I think about is on the square root is 0. You know, if you plug in x equals 3, then negative 3 plus 3 makes 0. So for this graph, I rearranged it a bit with some algebra. Okay, but we know that it's supposed to have a dot still. It's supposed to have a dot at 3. It's different this time. 1, 2. At 3 on the x, we have 0 on the y. Okay, but when you multiply the domain variable by a negative sign, you've reflected it about the y-axis this time, so it should be going in the reverse direction. So we can make a data table to check, but it should be going in the opposite direction with respect to the y-axis. And you could check by plugging in some numbers. We plugged in x equals 3. That got us y is 0. If you plug in x equals 4, let's see if that'll even work. According to our graph, our guess, it shouldn't work, right? Because there's no curve over here. And that's true, because if you plug in 4, 4 minus 3 is 1, and negative 1 is square root of negative 1. Or if you plug it in here, plug 4 in into either of our representations, it's not going to work. You're going to have a square root of a negative. So let's try plugging in 2. You can plug it into any one of these 3 representations, but over here, 3 minus 2 makes 1, square root of 1 is 1. And then the next one that seems to make the most sense is negative 1, because 3 minus negative 1 makes 4, and the square root of 4 is 2. You can pick whatever points you want to plug in here. I'm picking points so that I get nice clean integers. You could plug in x equals 0 if you want. You're going to get the square root of 3. You just have to change that to a decimal to help you graph. But look, our guess is correct because 2 on the x, 1 on the y. There's our dot. Negative 1 on the x, 2 on the y. It's matching up with our data table. So if you're ever unsure what those transformations are doing, go ahead and make a data table. The way I describe this one in words is I'd say that we transformed it 3 units to the right, and then we reflected it about the y-axis. So 3 units to the right, and we reflected it about the y-axis. This one, we just reflected it about the x-axis.